a look at some chemical reactions. So the basics of a chemical reaction is that you start with some substances. They're going to rearrange into some new substances. And so what we start with is called the reactants, and they change into the products. When this change happens, the atoms that are in the reactants simply recombine into new ways to form these products. It's important to note that these atoms are not destroyed, they're not lost, they're not created, and that's because matter is neither created nor destroyed. It is conserved. And we call that the conservation of matter. So whenever we deal with the law of conservation of matter in our chemical reactions, we have to make sure that the number of atoms, each element, are equal on the reactant side to the product side. Let's take a look at some examples. So here we're looking at the formation of water. So hydrogen gas mixes with oxygen gas and it forms water. So in order to make sure that this reaction is balanced, we have to make sure that the number of atoms of each element is the same on both sides. So what I like to do is make a list of those elements. So we have hydrogen and we have oxygen. We have the same elements on both sides, so we're off to a great start. And then we have to see how many hydrogens do we have. We're going to look at this little number down here. That's called a subscript. It tells you how many hydrogens there are. This one will tell you how many oxygens there are. When we look at a molecule like this, when we say H2, that means that there are 2 hydrogens. And then the next element that's in that molecule, we'll look at its subscript. Now, this oxygen does not have a subscript, so that means there's just 1. And as you can see, we do not have an equal number. Now, the only way we can balance an equation is by multiplying. In order to multiply, we're going to put a number in front of the molecules. This number is called the coefficient. So whenever I want to change the coefficient, I'm going to add a number in front of the molecule I need to change to make it even. So I don't want to multiply anything on this left side because that would make it even bigger than on the right side. So we'll start by multiplying on the right side first. And you can only put coefficients in the front of molecules. So we have to put it in the front of the water. And I'm going to multiply it by 2 because we have 1 oxygen and we need 2. So we have to multiply it by 2. So now we have 2 oxygens, but since we put it in front of that whole molecule, it's going to multiply by the hydrogen as well as the oxygen. So we have to multiply 2 times those 2 hydrogens, which will give us a total of 4 hydrogens. And now our hydrogens are not balanced. So we have to go back onto the other side and do some more multiplication. For this H2, if we want 4 hydrogens, we're going to have to multiply by another 2. And that will give us 4 hydrogens. And now everything is balanced. And if there's no number in front of the molecule, we just assume it is a 1. You can write the 1 if that helps you, but it is not required. If there's no number, just make sure you know that there is a 1 as the coefficient. Now, whenever we talk about conservation of matter, that means that the amount of mass at the beginning is the same as at the end. So they're going to have the same mass in the reactants as in the products, but that might not always be obvious whenever we're just looking at something. One example would be whenever you burn something. So if you burn wood, the wood is going to weigh more than the ashes. And there's a reason for that. So some of the reactants, as they changed their combinations to form the products, they formed products that were now gases or even things like water that evaporated. And so as these gases and this water evaporates to the surroundings, we're not always catching all of it to compare that mass. But if you do go to like a laboratory and you were to burn a substance inside of a closed container, you could measure the mass that is in that container, and you would find that the amount of ashes, gases, and any water that is in there will all add up to the same mass as that wood that you started with, as well as any oxygen that was needed to burn that amount of wood. Another example will be iron turning into rust. So iron is Fe, and whenever it is in the environment, it's going to mix with oxygen and form iron oxide. And you'll notice that we're dealing with rust, iron, and oxygen is a gas, while iron and iron oxide are solids. So the mass of this oxygen gas is going to be included in our total mass for the reactants. And our mass for the products, which is iron oxide, is actually going to weigh more than the iron. And that's because the iron essentially kind of absorbs the oxygen from the environment to form this rust. But what you'll also notice is that this equation is not balanced. So let's take another shot at balancing this equation. I'm going to make spaces for my coefficients. And whenever we multiply, we can't change these molecules. We can't change the little numbers. We can only multiply coefficients in the front. And we just have two elements here. Again, we have iron and oxygen. So on the first side, we have one iron. There's no coefficient, no subscript, so that's just one atom of iron. There's a subscript of 2 on oxygen, so we start with 2. And then on this side, you can cover up the next element if that helps you see how many there should be. So iron has 2, and then oxygen has 3. So if we want to make our elements match each other and be equal, our first step might be to make iron equal by multiplying this iron by 2. But now our oxygens are not equal, and whenever you have a 2 and a 3, it's very hard to make those equal by just multiplying one of them. So instead, we have to multiply them by each other. So we're going to multiply this 2 by 3 and this 3 by 2. But in order to do that, remember, this is one molecule, so we're going to put that 2 in front, and we actually have to multiply the iron and the oxygen. So now we have 4 iron and we have 6 oxygen. We have 6 oxygen on the left side, but our irons are not equal again. So now, instead of multiplying by 2, we're going to start over on the iron, and we're going to look and see what we can multiply by instead. And we can instead multiply by 4. So 1 times 4 will give us 4. And now we will have a balanced equation. 4 iron, 4 iron. 3 times 2 gives us 6 oxygen. 2 times 3 gives us 6 oxygen.